Crossed aldol reaction. Crossed aldol reaction is basically an aldol reaction that is happening between two different carbonyl compounds. You can take two different aldehydes or two different ketones, or you can take a mixture of aldehyde and ketone. Because we are taking a mixture of the carbonyl compounds, it's going to lead to the formation of four different products. Let's see how. Let's say that we are taking two different aldehydes here. In this case, we have propanaldehyde and we also have acetaldehyde. So here in this case, it has the ability to form two different types of enolates. Say for example, both of these compounds have got an alpha hydrogen. So compound A also has got alpha hydrogens and compound B has also got alpha hydrogens, because of which when they react with bases, they can form two different enolates. Here are the two different enolates. And these two different enolates can react with the carbonyl compounds to give four different products. The enolate which is produced from A can react with the carbonyl compound A, give us one addition product, but it can also react with B to give us the other addition product. And in the same way, the enolate which is derived from B can also react with A and B to give us two separate addition products. On the whole, there are four aldol addition products that are obtained in cases where both of these carbonyl compounds have got alpha hydrogen. But we can primarily get one product if one of these carbonyl compounds is lacking an alpha hydrogen. Let's say one of the carbonyl compounds that you choose for the aldol reaction does not have an alpha hydrogen, such as what we see in this case. Say for example, when you take benzaldehyde, it doesn't have any alpha hydrogen. So this is our functional group, and this carbon right here is an alpha carbon, but it doesn't have any hydrogen. When this is going to be reacted with another aldehyde or ketone in the presence of a base, what's going to happen is there will be only one enolate that will be created. This only enolate that is formed in the reaction can react with either benzaldehyde or with acetaldehyde to give us the addition product first, and then it can undergo condensation to give us the alpha beta unsaturated carbonyl compound. Now you can see that the four products have been reduced to two products with the use of a carbonyl compound which doesn't have any alpha hydrogen. But how can we primarily get only one product? For that, what we are going to do is we are going to take the carbonyl compound which does not have the alpha hydrogen along with the base together as a reaction mixture, and then add the compound with alpha hydrogen very slowly to this reaction mixture. So this is going to be as a reaction mixture, and then you will be adding this compound which has the alpha hydrogen to this reaction mixture. First, it's going to form the aldol addition product, and then when you react it with acid, it's going to form the alpha beta unsaturated carbonyl compound. Here you can see that this is formed as this one product has been formed in 90% yield. What is the reason why it primarily forms one product? Whenever you add this carbonyl compound which has the alpha carbon very slowly to the reaction mixture, first thing that's going to happen is it's going to create as an enolate ion, right? So this will be the enolate ion that will be created. Once it has created the enolate ion, it needs to go and attack a carbonyl compound. Now, since this carbonyl compound is present in low concentration in the reaction mixture, the chance for it to go and attack this carbonyl compound will be much higher. So it will go and easily attack this carbonyl compound and form the product, which would be this. This crossed aldol condensation reaction, where you're going to take two different carbonyl compounds in which one is an aromatic aldehyde or a ketone which does not have an alpha hydrogen and leads to primarily one product, is called as Claisen-Schmidt condensation reaction. When you're conducting the crossed aldol condensation reaction between two different carbonyl compounds, both of them having alpha hydrogen, in that case what you're going to do is you're going to take one of the carbonyl compounds and react it with LDA. In this case, we have to definitely use LDA because the LDA will make sure that all of this carbonyl compound is converted into its enolate. And then you're going to add the other carbonyl compound very slowly. Because all of this LDA has been used, a new enolate ion will not be created from this carbonyl compound, and therefore it has to only react as a carbonyl compound with this enolate to form only one product.